This is chapter 3, part 1. In this chapter, we're going to sort of look at research that has sort of examined the link between brain characteristics and serial murder, extreme forms of violence. And we're going to follow pretty closely to what the chapter 3 says, but I'll throw in a few extra things along the way. And you want to make sure and listen closely to these videos as well as reading the chapters, since I do at times bring in just additional information that I'm aware of. Experimental research in rats shows that frontal lobe damage is linked to uncontrollable violence. Now, of course, it's possible to do animal research where you can do damage to, say, the frontal lobes of the brains of rats or other lab animals. And we do that because ethically we couldn't do that sort of thing with humans. You couldn't intentionally do damage to the front part of someone's brain and to see if that affects their personality, see if that affects their behavior or their tendency to act violently. But research indicates that even the brains of these simple animals are similar enough to humans that we may not be able to learn about human tendencies from the results of animal studies. And certainly we know that in humans, the frontal lobes are very much responsible for our behavior, and and there's plenty of human research that shows that if damage is done to the front part, the frontal lobes of the brain, that it can lead to a tendency to act out violently. Often what happens is that the frontal lobe tends to be responsible for putting the brakes on impulses, angry impulses, strong negative emotions. This is a higher part of the brain that tends to be engaged in a lot of decision making and a lot of sort of logical, high level forms of thinking, decision making. That high level thinking tends to put the brakes and restrains our more primitive drives. And emotions tend to operate at sort of a kind of a more ancient or primitive level. And so the frontal lobes in the brain is a part of the human brain, which is sort of more recently evolved. If you look at evolutionary research, that these higher levels of the brain are more recently evolved and are very dominant in human beings, and are less evolved and less dominant in simple animals. So the point here is that if you get damage to that very important frontal part of the brain, that you might not have that check, that brake on strong negative impulses. And so if you get really angry, you may strike out and hurt somebody because you don't have a brain that's functioning properly to be able to restrain yourself, to restrain your impulses and to not act violently even though you want to. Similar damage in humans can result in negative personality and mood changes and violence. Now, I forget whether this is described in the textbook, but there's a famous case in the brain sciences and neuroscience of Phineas Gage, who worked in mining. I believe it was, I forget the exact time period, but it's at least more than 100 years ago. And he was involved in an accident, an explosive accident, where the dynamite went off, and he had been basically a metal rod from the explosion, a metal rod that was used to kind of tamp dynamite into a deep hole in the rock to break up rocks. That metal rod shot out of the hole due to the explosion and went actually through his brain. And prior to that accident, he was a very friendly, easygoing, amiable, nice guy that everybody liked, popular guy, very pleasant personality. Well, amazingly, he was able to survive that horrible accident, even though that metal rod went through his brain and out the back side of it. He was able miraculously to heal from that, but his personality was forever changed. He was much more unpredictable, unreliable. He had been a good worker before, and after the accident, he was unreliable and had, sort of odd mood swings. He was much more moody and difficult and didn't get along with people. And he just basically did not function like he did before. So it changed his personality to have damage done to that front part of his brain where the metal rod went through. So that's a famous case of how someone can change dramatically through brain damage and can, could potentially uh, be involved in criminal behavior or violent behavior much more after the accident than before the brain damage. In one study, this is an important line of research that's really growing and emerging now. 94% of homicide offenders had dysfunction in the frontal lobe compared to 3% of the general population. If you go into a prison and get a sample of prisoners, especially violent prisoners, those convicted of violent crimes like homicide, what you often find are some brain difficulties. You find very often lesions, damage that's done to the brain, that these individuals tend to have a life history where a lot of damage has been done to their brains, whether it's through accidents, through maybe, a lot of times when you're young, especially boys will engage in reckless behavior and fall on their heads or get, maybe could get hit by a car, for example. I mean, I have an experience of a personal experience of a friend who had a perfectly well-behaved teenager who was hit by a car, and he, being hit by that car, did terrible damage to his brain, and he, a little bit like Phineas Gage, his personality was changed after that damage was done to his brain. But it can be in less dramatic forms, where just being a victim of physical abuse, getting beaten up by kids at school, bullied, being abused, physically abused by parents or other people at home, siblings at home. Any of that could cause brain damage, which what it tends to do is reduces the functioning of the brain. The brain doesn't work like it's supposed to if it's been damaged, and it may not repair very effectively after that damage is done. So you see with a lot of these homicide offenders in prison, uh, lots of brain damage that you take, pictures of the brain, do imaging of the brain, and you see a lot of indications of damage throughout the person's life. So that could very well be contributing to their violent behavior. Here, this particular study is focusing on just the way the brain is wired, the way the frontal lobe of the brain is wired. If there's indications that it's not working properly, that this is a problem much more often among homicide offenders than it is the general law-abiding population. So this is the type of research which shows brain problems being linked to violence. Brain tumors have been linked to violence. I'm not sure if we'll have time. We might have time this semester for me to present to you folks a case study of Charles Whitman, who in 1966 went up into a tall tower at the University of Texas in Austin and proceeded to shoot down upon the students and faculty, etc., down below all around the campus. And he was able to kill and harm many people from that tower. And he was finally stopped and killed by law enforcement. And when they did an autopsy, they found that he had indeed had a brain tumor that was close to his amygdala, which is an emotional center of the brain, a place that's very much involved, a region of the brain that's very much involved in anger, aggression, negative emotions, stress, anxiety, various types of aggression. And that the brain tumor was indeed pressing on that emotional center of his brain. And before he committed this crime, he he saw a psychiatrist and reported to like his wife and other people that he was having. I don't now that I think about it, he might have kept this to himself and just only put it in his journal. But we have evidence anyway that he was reporting disturbing, violent thoughts that he couldn't control right before this crime occurred, and even saw a psychiatrist over his troubles. and he had different troubles with school, and he was in the military and had problems there. And so evidence that this brain tumor could have been a key development behind his violence. Didn't have a history of violence prior to this mass shooting uh, that he did. So anyway, we might have opportunity to show that as a case study. It's a good one. Um, but that's an example of where brain tumors may be implicated in helping to cause this disturbingly violent behavior. Abused kids might develop quick triggers to deal with threats. Combine this with social deficits, and you might get violence. So, of course, we're going to take the point of view this semester that this sort of extreme violence is probably caused by lots of different factors. Because if you think about it, um, these are rare individuals. There's only, maybe a few dozen serial killers who are on the loose at any particular time in the United States. That's way too many, but it is a rare sort of criminal. So if you have a rare type of criminal, then it must be a rare sort of set of causes that would cause someone to engage in a rare sort of crime. So it wouldn't be alone. We mentioned here abused children, and indeed, being abused is a common background risk factor that you see among these serial killers. But it doesn't really make sense to put it all on abuse because research shows us that many children, it's not rare at all. Maybe 25, 30% of children, if we're focusing on different types of abuse, let's focus on physical abuse. A significant percentage of children are physically abused when they're growing up, but you don't have, let's just throw out that number of 30%. You don't have 30% of grown up Americans as serial killers. It's a very rare form of criminality. So abuse alone is not likely to explain serial killers, because if it alone explained it, we would have millions of serial killers because there's a lot of abused kids. Most kids who are abused don't grow up to be serial killers. So that sort of logic indicates that it's got to be a set of factors, some of them potentially not very common, like that brain tumor that we just talked about, that can produce an unusual form of criminality. And here we're talking about serial killers. So just keep that in mind. But the point that we're making here is that abused children, what might happen if you were abused a lot when you're growing up, you may learn to uh, develop what they could call a trigger. That if you think that if let's say you're hurt a lot by a grown-up, you're physically abused, you may learn to react to that very quickly, to be sensitive to threats of danger, and to sort of develop a hair trigger where, let's say this translates over to a school situation where you might feel threatened by a, a child at school, and you may strike out quickly. You may develop this sort of hair trigger and may actually act out violently because you've learned to be very sensitive to threats because you've been hurt a lot, and it might cause you to react to even small threats from school or wherever, in a very extreme, harsh kind of way. And when you combine that together with social deficits, by that we mean people here, all kids can struggle to get along with other kids and to be able to express themselves in a positive, constructive way and to control their emotions and just be able to get along with other people. It takes skills. Not everybody can get along with other people really well. Some people are just, have a hard time getting along with other people. And so when you combine these different deficits, kind of challenges together, then there's a higher and higher risk that you're going to have behavior problems and potentially some violence going on. PET scans, a form of imaging of the brain, um, where they measure glucose metabolism. That just means basically your brain is run on glucose, basically sugar. Sugar is energy in your body, and your brain needs a lot of it to do its work. And so you actually measure how much energy your brain is using to do different mental activities. So these PET scans and this measuring the use of glucose indicates, those sorts of studies indicate that impulsive and aggressive people show less brain activity. The activity is also abnormal, especially in the left hemisphere among violent people. So here you're seeing some brain differences again. And this is not only these PET scans types of research studies, but also various types of studies tend to show that you get less, you get quieter, lower level brain activity. You're likely to among people who are violent. And what the theorists have to say to try to explain this is that people who have a brain that's set, its activity is sort of set at a lower level, and also a level that shows sort of abnormal patterns, that this sort of person may be more likely to be violent because they sort of crave intense stimulation. They say that they call this being under aroused, that if your brain is kind of set at a low level of activity, that makes you crave extreme sensations. You're easily bored. You're bored with normal activities. They don't stimulate you. You don't react well to them. You kind of underreact to stuff. So you need really extreme sensations to feel satisfied, to not feel bored, to feel like you're getting enough stimulation to stay interested in things. Well, crime and violence is extremely stimulating activity. It's life and death sometimes. It's, am I going to get away with this crime or am I going to prison? It's very, uh, not to make it sound positive, but it's very exciting. It's scary. And some people get really attracted to that. Other people would be overwhelmed and terrified. A person who has a more sensitive wiring is wired to have much more brain activity. That's the kind of person, according to this perspective, the kind of person who would be perfectly content and happy and satisfied to sit in the corner and read a book. And they don't need any more stimulation than that. They're perfectly satisfied to sit and look out the window and watch the grass grow because they don't need much to feel stimulated enough, like there's enough going on where they're not bored. So that sort of person, according to this research, would not be likely to be a criminal because crime would be way too much for them. They couldn't handle it. But that for a certain kind of person with a certain sort of brain wiring, crime and violence may be an attractive activity. So again, the big picture here is that we're seeing differences in brain patterns, brain activity, brain functioning, brain health as being related to violent behavior. MRI scans and other sort of imaging of the brain shows that antisocial individuals have 11% less gray matter in the prefrontal area. They do not differ in the white matter. The white matter of the brain is the part of the brain that supports the gray matter. The gray matter is doing all the thinking, doing all the activity of you know, uh, sort of reading and interpreting your environment and making sense out of things. All the thinking that you're doing is the activities in this gray matter of your brain. The white matter is sort of supporting that, and so think of it as a supportive role. So what this research is saying is that people who have criminal tendencies, that's this antisocial, is just another way of talking about people with criminal tendencies, is that they tend to have less of this gray matter. The gray matter is what does the thinking, and makes your decisions and runs your behavior. And so if you have less of that gray matter, basically what it sounds like, what it seems to be indicating, is that in the frontal lobes, which I said before is very important, frontal and prefrontal is just another area in the front of the brain, where that's very important for decision making, for judgment, for controlling your strong emotions and impulses. And so it could be that if you have sort of less of this type of brain material, brain matter, that you may not be quite as good in judgment and your decisions may not be quite as sensible. You might suffer from a little bit of poor judgment and you may act without thinking. And you may not plan your behavior and just go more on impulse, which sometimes can get you into trouble. Because one thing that's clear about most violence is it tends to be very impulsive, spontaneous. People don't don't think before they start attacking somebody. So at least for spontaneous sorts of violence, this seems to be relevant. And again, it just points to a brain that's not functioning in an optimal sort of way. Research shows that the structure of the prefrontal cortex, again, this part of the brain that's very important to high-level thinking, for example, gray matter volume, how much gray matter there is under considerable genetic influence. So again, this chapter tends to focus on the functioning of the brain, but of course, the brain, how it functions, how it develops, the structure of it is very much influenced by genes. Not only when a person is a brand new embryo, developing in the womb. Of course, the genes are sort of the blueprint. They're in control of the development of cells and all the operations, the activities in cells, the brain cells. We're focusing here on the brain, the body too, but we're focusing on the brain. And so, but genes are not only important for the development of your brain, but also as you grow up for how that brain functions, because the genes are in charge of what they do is they produce proteins, which lots of different kind of proteins, which are all involved in the operations of these brain cells. And so, and some genes are going to produce healthier brains, and some genes are going to be less able to produce healthy brains that are working at optimal level. So there is a strong, important genetic influence to brain function here. So we have to understand that role in this. And let me say that the science in this area, where you're talking about brain structure, brain functioning, where you're talking about genetic role, genetic influence, is rapidly growing area of research. Is super sophisticated. It's hard to keep up with it and even understand some of it. Very sophisticated. So it is teaching us that indeed the brain is very important for people's behavior. There's no behavior that you ever engage in that's not run through the brain. It comes from the brain. The brain is in charge of everything you do. And if you do bad things, the brain's probably not quite working like it's supposed to. And then of course there's this sort of this genetic influence, which is part of the story of how the brain is operating. Well, we're about 20 minutes into this, or 20 plus into this segment. So let's stop here and we'll continue on in part 2.